Okay, this is example 7 in your book. I think it's a very good example, so I do want to go over it. And again, there are a lot of intermediate steps that they missed here, and I'm not sure if everyone is familiar with the rational roots theorem and how they found all these factors. So I did want to go through it. So here's our differential equation, and it's okay. So our order is 3, and again, our characteristic equation is going to be that's equation, and it's going to be r cubed plus r minus 10 equals 0. And here, if we try to factor this, it's not a quadratic, so we know we can't use a quadratic formula, but you can't factor a GCF, right? Because, I mean, this has at least one r and r, but this has no r. So it's not factorable. Well, there is no GCF. You can't just, do the two parentheses because you don't have a quadratic. That's only if you have a quadratic equation. So what do you do next? I mean, what do you just say there's no solution? So here, this is where it goes back to, again, to algebra. So we're going to use two things. One thing is, one theorem, it's called a rational roots theorem. Okay, and we're going to combine that actually with synthetic division or long division, whichever your preference is, because we want to know at least one root. If we can get at least one root, then we can obtain the other two roots. Right, because we're here. I mean, we have 3 roots, so if we can find one, then there's only 2 left to find. So the rational roots theorem basically says, so you have, in algebra, I think they might have called this, so we know this is 1, right? I think they might have called it P and Q, M and N. I mean, it really depends on the book. So we have these two constants, and we want to find the factors of these guys. So in other words, we want to take 10, and don't worry about just take the 10. Don't worry about the negative because we're going to use it anyway. It's going to be, you take 10 over 1. So again, I'm guessing P and Q. I don't know if they call it QP or PQ. But you're going to take, and that's just to be consistent here, you're going to take Q over P, and Q over P is just 10 over 1, right, which is 10. Okay, so you want the factors of 10, okay? Not necessarily prime factors, but just factors. So what numbers are divisible by 10? Okay, so this is where this comes in. Well, we know 1, right? 10 divided by 1. 10 divided by 2, right? 10 divided by 5, and of course 10 divided by 10. And, I mean, these are rational roots, right? So, I mean, rational meaning fractional. Here's, right, your fraction, but it's really 10. But we can talk about the positive and negative roots, positive and negative, positive and negative, and positive and negative. So, I mean, really have 2, 4, 6. So we have 8 possible roots. Okay, one of them, it might be 1, it might be -2, it might be -10, right? But again, these are possible roots. Not all of them are roots. And so that's why they have that, if you're reading the book, right, they have these factors. And so now they say that the book says we discover the root 2. Okay, so how did they find 2, if you're wondering? So this is where we're going to use our synthetic division, right, to find our root. So whenever it's not a quadratic, and obviously you're working with a higher power, you're most likely going to use synthetic division. You can use long division, but, synthetic division is easier. You don't have to work with the variables, and it's just a lot shorter. So what do? Okay, so we try, and I'm going to try one that doesn't work, just because on your homework, you might not get the first one right, meaning picking that first root. This is really trial and error. So I'm going to say let's try, oh God, let's see, if I want to, well, yeah, let's just do 5. Okay, so if I try 5 using synthetic division, okay, I'm going to put up 5 here. I'm going to put my little box. Again, each book is different. Whoops. How they use the synthetic division, or actually write it out. And then I'm going to write the coefficients of my polynomial. So what are the coefficients of my polynomial? And it looks like they are 1. And notice it's okay, it's r squared. Let's actually rewrite this. So this is fine. I just actually I want to write this again. So you have, okay, r cubed plus r minus 10. Okay, that's really 1 r cubed, we know that. But we're missing an r squared, so we have to write it in, plus r squared, plus, of course, 1r minus 10. Okay, so we want to use these coefficients. So I'm going to write 1, 0, 1, and negative 10. And again, just want to write this nicely. So 5, and then 1, 0, 1, negative 10. Okay, so then you're going to draw a little line, a horizontal line here, and you're going to perform the synthetic division. And basically, right, you just always drop down the first one, and you're going to multiply, add, multiply, add. This direction is multiply, right, and this direction is adding. So if I drop down to 1, 5 times 1 is 5. Add these guys. 0 plus 5 is 5. 5 times 5 is 25. Then I'm going to add, and I get 26. 26 times 5. Okay, well, 26 times 5. Okay, well, let's just do this on the side. So we get 13 and 130, so we get 130. Now, if you add these guys, 130 minus 10 is 120. Okay, the very last number, that is actually the remainder. And if it's a root, the remainder is going to be 0. Okay, this is not 0, so that's how we know it's not a root. So if when you're testing these out, if you want to write out 1, well, you can say 1, 2, 5, 10, and then of course negative 1, negative 2, 5, negative 10. And we tried 5. Okay, 5 doesn't work, so I'm going to cross that out. Okay, so now again, it doesn't have to be in a specific order. So let's try 2. So if we try 2, okay, I'm going to put 2 in my little box here. And I'm going to use my same polynomial, so 1, 0, 1, negative 10. Draw my horizontal line, drop my 1. 1 times 2 is 2, add these. 2 times 2 is 4, add these. 5 times 2 is 10. Well, it's really positive 10, so negative 10 plus 10 is 0. So we get a 0, so we're happy campers, right? So we know we're done, right? That means this implies, right, all this work implies that 2 is a root, right, of our polynomial. What was it? R cubed plus r minus 10. Meaning, if you plug in 0 into r, you actually get 0. Or if you plug in 2, sorry, you get your 0. Okay, so let's break this. Now that we have this part, now let's write, let's see. Okay, the fact that 2 is a root, okay, 2 is a root means r minus 2, right, is a factor, right, of this polynomial, right? Because if you set this guy equal to 0, right, r is 2. So we know r minus 2, right, is a root, and then you have a resulting polynomial left. What is that resulting polynomial? It is, let me get another color, I'll do blue. It's these numbers here. But remember, this is r cubed, right? This was really represented, okay, that shouldn't be blue, r cubed, right? That was 0 r squared, that was 1 r, and then of course negative 10. So you divided so by r, so you know the power is going to drop. So this guy is going to be, what, 1, or r squared, plus 2r, and then plus 5, right? That's usually the constant. And then that's going to be equal to 0. If you multiply, whoops, didn't want to do that. Okay, let me write it again. Sorry about that. What did we have? 1, well, r squared plus 2r plus 5. Yikes, it's already past 10 minutes. Okay, well, let's see, maybe, okay, let me actually stop here, and then I'm going to continue, just because it's going to get very long. It's good to take a break anyway. So I will continue in the next video.